The muscular, nervous, cardiac, and endocrine systems all connect with the digestive system to play a role in how your domestic cat eats and digests food in its normal diet. Cats are obligate carnivores, which means they evolved to eat a diet of animal protein or an all-meat diet, and their digestive system adapted to accommodate that. First, food enters the mouth and then is transported through the esophagus down to the stomach, where it begins to be broken down. The small intestine does the majority of the digestive work and then moves what's left to the large intestine, where nutrients and water are absorbed. And then whatever is left over as waste ends up in the rectum and eventually is eliminated through your cat's anus. Your cat's mouth begins this work by using muscles to acquire, hold on to, and move food into the esophagus. And the nervous system is sensing the presence of this food, signaling the brain to tell the body to begin the digestive process, which includes having the endocrine system produce salivary secretions to lubricate the food. This whole time, the cardiac system has to be gearing up to provide increased circulation to accommodate the increased need for oxygen and energy during digestion. In the esophagus, muscles contract to push food through it, and the nervous system is continuing to register that there's food there, telling the endocrine system to produce mucus and lubricate the food, while the heart's working to supply blood and oxygen to the rest of the digestive tract in getting it prepared to receive the food. In the stomach, muscles are contracting to break down food into smaller pieces, and at the same time, enzymes are mixing with that. The nervous system signals the endocrine system to begin chemical digestion and produce these enzymes to help break down the food, along with mucus and hydrochloric acid that are already in the stomach. Cardiac output remains elevated during this time to ensure that the stomach has increased energy and blood supply. Most of this liquefied food that's now a slurry called chyme or digesta moves to the pylorus that takes it into the small intestine. While in the small intestine, the nervous system is maintaining communication with the endocrine system and signaling it to produce enzymes for the final stages of digestion to break down that chyme. And this includes the pancreas providing enzymes to the small intestine, the liver secreting bile, which goes into the gallbladder and is stored until it's needed, where it's then moved into the small intestine to break down lipids or fats. This is really metabolically taxing and takes a lot of energy. Your cat has to digest, move, and absorb food, and the heart ensures that oxygen and blood continues to circulate where it's needed at an increased rate. And then muscles are performing peristalsis, which is also so important that it has its own slide. So smooth muscles in the walls of the small intestine are performing these coordinated contractions and relaxations to mix and move the chyme through the small intestine and into the large intestine. Peristalsis is regulated by the nervous system and the endocrine system, communicating through hormones to tell muscles to do their job. When the food reaches the end of the line, or what's left of the food, the nervous system and endocrine system are producing electrical and chemical or hormonal signals that tell the large intestine to finish up digestion. Bacteria breaks down any remaining undigested food and produces vitamins. Remaining water is absorbed, and this leaves solid waste. Muscles in the colon contract to move the solid waste towards the rectum, where it is stored until defecation happens, and the anal sphincter muscles relax, allowing that feces to leave the cat's body. The heart continues to maintain circulation, delivering oxygen and nutrients to the cells of the intestinal wall and removing waste products. What about wild felids, though? Well, as I mentioned in the beginning of our story, cats are obligate carnivores, and so are their wild conspecifics. The digestive anatomy and process of wild felids differs slightly depending on the species. So domestic cats evolved around humans, where food is abundant and frequent meals are easy to find, not only from food people throw out, but from rodents that people attract. Wild felines, like lions, for example, live where food might be scarce, prey might be difficult to catch, manage, and eat. And so what does this mean for how their digestive system might differ from that of your cat? Well, cats have a short digestive tract adapted to eat small meals frequently. So your cat really needs to eat often and not too much at once, while lions have a longer digestive tract, allowing them to eat larger meals less often. They can eat a big meal and then go several days or even a week without eating. Lions also have a larger cecum than your cat and can break down some plant material and extract more nutrients from things like bones and other prey parts that your domestic cat can't. How might feline digestive processes contrast with those of herbivores like horses, gazelles, giraffe, and manatees? Manatees are marine mammals. They're herbivorous, and that means they eat plant matter and no meat. They live in water, so they have to eat aquatic plants like seagrasses. Their digestive system has evolved to digest forage that they find in the waters where they live. They have a simple stomach, but their intestines are very long and coiled, which increases surface area, allowing for longer digestion. Manatees have evolved hindgut fermentation, which is an adaptation where microbes in the cecum metabolize cellulose and other tough plant pieces the stomach and small intestines can't. Remember that cats are carnivores and have adapted to digest an all-meat diet. They will do best if they're fed small meals several times a day, and their digestive system is just not adapted to process plant material. Please direct any further questions to Dr. Doolittle's Animal Hospital.